So we want to find the doubling time of our equation where x is in hours, and it wants us to round our final answer to 3 decimal places. So just like finding the half-life, finding the doubling time, you're basically looking for x when our y is twice as much as we started with. So we know that this is the same thing as an exponential equation, which is in the form y equals c times a raised to the x. Sorry for my sloppy writing. And we know that our c is our initial value. So like I said, we're looking for x when our y is equal to twice our initial value, what we started with. So we can set that up like this. It's going to be 40 because that's twice the amount of 20 is equal to 20 times 1.28 raised to the x. And now we just solve for x the way that we normally do. Because 20 and 1.28 to the x are being multiplied, we are going to divide both sides by 20 and get 2 is equal to 1.28 raised to the x. And then because we're looking for x and it's in the exponent, we have to do the opposite and turn it into a log. So remember, the base of your exponent becomes the base of your log. So it's going to be log base 1.28. And then what goes inside of our log is what our previous equation is equal to. So that's this 2 right here. And it's always going to equal our exponent because that is what we are ultimately looking for. So you can plug this into your calculator. If you can change the base of your log in your calculator. If not, we can use the change of base formula, which is going to be log base 10 of 2 divided by log base 10 of 1.28, because remember, it is your log of divided by your log base, and that's going to equal x. And then when you plug this into your calculator, you're going to get 2.80785, yada yada yada. And then it wants us to round to 3 decimal places, so that's going to be 2.808. And then don't forget your units, we are in hours.